Alright guys, in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So to solve this, what I'm first going to do is I'm going to factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x, that's simply 1. So I have 1 plus, again, it's the same thing, 1 plus, final time, the same thing, and this is equal to 333. Now, if I add what's in the parentheses, I get 3. So now I have 3 to the power of x times 3 is equal to 333. So now I obviously want to isolate 3 to the power of x because this is the term that has the variable x that we're solving for. So I want to try to find a way to get rid of this 3. So to do that, I'm going to divide both sides by 3. Now, these two 3's simply cancel out, and I'll be left with 3 to the power of x is equal to 333 divided by 3, which is 111. So now I got this equation, 3 to the power of x is equal to 111. So to solve this, what I'm going to do is I'm going to take the log on both sides. So now I have log 3 to the power of x is equal to log 111. So now, if I have something in the form log a to the power of b, I can actually move this exponent and b to the front. So this is going to equal b times log a. So for log 3 to the power of x, I can move x to the front. So now that would lead to me having x times log 3 is equal to log 111. So now what I'm going to do is I'm going to divide both sides by log 3. So then for my left-hand side, these two log 3's simply cancel out, and I'll be left with x is equal to log 111 over log 3. So now, if I have something in the form log a over log b, this is simply equal to log base b of a. So in this case, I have log 111 over log 3, and I can write this as log base 3 of 111. So this is my answer. Alright, so in this problem, I have 2 to the power of 22 minus 2 to the power of 21 is equal to 8 to the power of x. So I know at first glance, this problem looks pretty complicated. However, it's actually easier than you might think it is. So for this problem, I'm solving for the value of x. So for my solution, first start with 2 to the power of 22 minus 2 to the power of 21 is equal to 8 to the power of x. Now, it's 22 here. This is the same thing as 21 plus 1. So I'm going to rewrite this as 2 to the power of 21 plus 1 minus 2 to the power of 21 is equal to 8 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 21 plus 1, I can rewrite it as 2 to the power of 21 times 2 to the power of 1. And I still have minus 2 to the power of 21 is equal to 8 to the power of x. And now, from here, 8, that's the same thing as 2 to the power of 3. So now I have 2 to the power of 21 times 2 to the power of 1 minus 2 to the power of 21 is equal to 2 to the power of 3 to the power of x. Now, for my left-hand side, if I factor out 2 to the power of 21, I get 2 to the power of 21 times 2 to the power of 1 minus 1. This is still equal to 2 to the power of 3 to the power of x. Now 2 to the power of 1, that's equal to 2, and 2 minus 1 is 1. So I'm left with 2 to the power of 21 times 1 is equal to 2 to the power of 3 to the power of x. Now anything times 1, it's simply itself, so 2 to the power of 21 times 1 is simply 2 to the power of 21. So I have 2 to the power of 21 times 2, is equal to 2 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x, that's going to equal 2 to the power of 3 times x. So I have 2 to the power of 21 is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 21 is equal to 3x. So I have 21 is equal to 3x. All I have to do to solve this is simply divide both sides by 3. These two cancel out, and I'll be left with x is equal to 21 divided by 3, which is simply 7. So x equals 7 is my answer. Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1. So to solve this, the first thing I'm going to do is I'm going to factor out 4 to the power of x from my left-hand side. So now I have 4 to the power of x times, now 4 to the power of x divided by 4 to the power of x is 1, so I have 4 to the power of x times 1 plus 1 plus 1 plus 1, and this is equal to 1. Now 1 plus 1 plus 1 plus 1 is simply equal to 4. So now I have 4 to the power of x times 4 is equal to 1. Now 4 here, that's the same thing as 4 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 to the power of x times 4 to the power of 1, that's going to equal 4 to the power of x plus 1. Simply just add these two exponents. And this is equal to 1. Now, anything to the power of 0 is simply equal to 1. So I can simply replace 1 here with 4 to the power of 0. And the reason I did that was to make these two bases the same. So now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So I simply just set the exponents equal to each other. So I have x plus 1 is equal to 0, and this is a simple equation. All I have to do is subtract 1 on both sides. These two cancel out, and I'll be left with x is equal to negative 1. Now, I actually have a second method of solving this problem. So again, we first start with 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1. Now again, I'm going to factor out 4 to the power of x, so I get 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1. Now if I simplify it in parentheses, I get 4 to the power of x times 4 is equal to 1. Now this time, instead of multiplying these two, I'm simply going to divide both sides by 4. So then these two cancel out, and I'll be left with 4 to the power of x is equal to 1 over 4. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 1 over 4, that's going to equal 4 to the power of negative 1. And now, since these two are equal to each other, the exponents are equal to each other as well. So I'm left with x is equal to negative 1 again. So that's two ways of solving this equation. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x minus 1 is equal to 2 to the power of x. Now, if we have something in the form a to the power of m plus n, this can actually be written as a to the power of m times a to the power of n. So as you can see here, we have 3 to the power of x minus 1. This can be written as 3 to the power of x times 3 to the power of negative 1. And this is equal to 2 to the power of x. Now I'm actually going to divide by 2 to the power of x on both sides. So now we have 3 to the power of x. And I'm actually going to move the 3 to the power of -1 to the denominator, and now it's going to be 3 to the power of +1. So now we have 3 to the power of +1 times 2 to the power of x. This is equal to 1. Now I'm actually going to multiply both sides by 3. So now these two cancel out, and you're left with 3 to the power of x over 2 to the power of x is equal to 3. So now this can be written as 3 over 2 to the power of x is equal to 3. Now if I take the ln of both sides, we get this can actually be moved to the front of the ln because this is an important property of logarithms. So now we have x ln 3 over 2 is equal to ln 3. And now I'm actually going to divide both sides by ln 3 over 2 so I can isolate x. So now these two cancel out, and we are left with x is equal to ln 3 over ln 3 over 2. Now, although this is a fine answer, this can actually be simplified because if we have something in the form ln a over b, this is actually equal to ln a minus ln b. So ln 3 over 2, this would equal ln 3 over ln 3 minus ln 2. So this is our answer.